So guys, 12.1, we are going to be translating and constructing line segments, so that's kind of what we're doing. Today we're just going to be looking at the distance between segments. So that's 12.1. So let's look at problem 1. Where are you? Dawn, Frida, and Bert live in a town where the streets are laid out in a grid system. That's actually very, very close to real life. If you guys have ever noticed, all of our streets kind of look like a grid, right? They're all either running north and south or east and west. Dawn lives 3 blocks east of Descartes Avenue. So I'm going to underline Dawn in pink. Dawn lives 3 blocks east of Descartes Avenue and 5 blocks north of Elm Street. Frida lives 7 blocks east of Descartes Avenue and 2 blocks north of Elm Street. We want to plot points to show the locations of Dawn's house and Frida's house on the coordinate plane, and then we're going to label each student or each location with the student's name and the coordinates of the point. So let's do Dawn together, okay? So we're going to start, he lives 3 blocks east of Descartes, so we need to find Descartes first. Where do you guys see Descartes? So, Dawn is 3 blocks east of Descartes. So where's Descartes, guys? It's this first one, right? Yeah. So let's start at 0, 0. And let's go 3 blocks east of Descartes. So that means I'm going to go to the right. So 1, 2, 3. And then he's 5 blocks north of Elm. Elm is the first one on the bottom. So that means we're going to go up 1, 2, 3, 4, 5. Okay. So put a dot there. Let's label it Dawn. What are the coordinates of that point? 3, 5. So put that next to Dawn. Okay. So guys, do Frida for me really quick. Okay, so it says that Frida is 7 blocks east of Descartes. So from 0, 0, how many spaces are we going to go over? 7. And 2 blocks north of Elm. So we're going to go up 2. So you should have put a point right there. Label it Frida. I'm going to label it right here, Frida. And what are the coordinates of her point? 7, 2. Good. That should be easy, right? Okay. So what we want to do next, and you guys can do this without me, name the streets that Dawn lives on, and name the streets that Frida lives on. So where does Dawn live? Oak Street and Euclid Avenue. So let's write that. Dawn lives. Where those two cross, what do we call that? Intersection. So Dawn lives at the intersection of Euclid Street. Oh no, Euclid Avenue, sorry. And Oak Street. Okay, do Frida for me. Guys, where does Frida live? What intersection? Boiler and Maple. Okay, so Frida lives at the intersection of Boiler Avenue and Maple Street. So far, so good? Okay. Okay, so we have Bert, and it says that Bert lives at the intersection of the avenue that Dawn lives on and the street that Frida lives on. Plot and label the location of his house on the coordinate plane, and then describe the location of Bert's house with respect to Descartes Avenue and Elm Street. So we're going to want to give his location just like Dawn and Frida's was given to us. So if he's at the intersection of the avenue that Dawn lives on and the street that Frida lives on, what intersection does Bert live? Where? 3, 2. Do you guys agree? Yes? Okay, so he should live on Euclid Avenue and Maple Street, right? So this is Bert, and he's at 3, 2. Okay, how does that relate to Descartes Avenue and Elm Street? So how many blocks from Descartes does Bert live? 3 blocks east of Descartes, and how many blocks from Elm? 2 blocks north. Okay, so that's what you should have written. So something like Bert lives 3 blocks east of Descartes Avenue and 2 blocks north of Elm Street. Okay? All right, so then let's look at number 3. How do the x and y coordinates of Bert's house compare with the x and y coordinates of Dawn's house and Frida's house? What did you guys notice?
Dawn's x coordinate same Bert's.
Okay.
And Frida's y coordinate same Bert's.
Perfect. That's exactly what you should have. So Dana said that Dawn's x coordinate, which is 3, is the same as Bert's x coordinate, which is 3. And Bert's x coordinate is 2, and that's the same as Frida's y coordinate. So the x coordinate is the same as Dawn's, and the y coordinate is the same as Frida's, which should make sense, right? So write something like that. All right? So the x coordinate of Dawn's and Bert's houses are the same, and the y coordinate of Frida's and Bert's houses are the same. Good. So now I want to know, or I want you to use Dawn's and Bert's house coordinates to write and simplify an expression that represents the distance between their houses. And then we're going to explain what this means in terms of the problem. So let's look at the graph again really quick. I want to know the distance between Dawn's and Bert's house. What do you guys think we could do? We could subtract. What would we be subtracting? 5 and 2, because they just live north of each other, right? So we're going to do, to get the distance between Dawn and Bert's house, we are going to subtract 5 minus 2. And what does that come out to? 3. So what does that mean? If they have 3 blocks in between them, whose house is further north? Dawn. So we would say that Dawn lives 3 blocks north of Bert. Okay? Okay, guys, so what was the expression that you used to represent the distance between Bert and Frida's house? 7 minus 3, which comes out to what? 4. Okay, so what does that mean? Frida lives 4 blocks east of Bert. Good. Okay, so now the question is, all 3 friends are planning to meet at Dawn's house to hang out. Frida walks to Bert's house, and then Frida and Bert walk together to Dawn's house. So here's kind of how it's happening. Frida is going to walk to Bert's house, and then the 2 of them are going to walk to Dawn's house. Okay? So I want to know, or want you to use the coordinates to write and simplify an expression that represents the total distance from Frida's house to Bert's house and then to Dawn's house. So how did we represent distance from Frida's house to Bert's house? Subtracted 7 minus 3, right? So that's going to be 7 minus 3, because that's how we figured out the distance. Now, Frida and Bert together are going to be walking from Bert's house to Dawn's house. So what are we going to have to do? Add, and what was the expression from Bert's to Dawn's? 5 minus 2. Okay, simplify that really quick. And then answer part B in the sentence. So guys, 7 minus 3 gives us what? 4 plus 3, which comes out 2. So how far in blocks does Frida walk altogether? Frida walks 7 blocks. Good. Is that the fastest way for Frida to get there? To get to Dawn's house?
No. Well, she goes diagonal.
She could go diagonal, so let's read number 7. Draw the direct path from Dawn's house to Frida's house on the coordinate plane. So, we're going to draw the direct path, so from Dawn's house to Frida's house. So we're just going to go diagonal straight from Dawn's to Frida's. Okay, because going Frida to Bert's house to Dawn's house is not the fastest way to get there, right? So if we go directly from Frida's house to Dawn's house, now let's flip it over. If Frida walks to Dawn's house on this path, how far in blocks does she walk? Explain how you determined your answer. Okay, guys, what shape do you see? A triangle, and not just any kind of triangle. What kind of triangle specifically? A right triangle. So what theorem could we use to define the distance of D? Pythagorean theorem. So, we need to identify a variable. So let's say that D is the distance from Dawn to Frida's house. Okay, so we do need to identify a variable. So anything that I write down, if you don't have it written, make sure that you do have it written somewhere. I don't just want the answer. Caleb, who just wrote the answer. Okay, so guys, if we're going to use Pythagorean theorem, that would be D squared equals what? What are our legs? 3 squared and 4 squared. Okay, so let's do the math. So D squared equals, 3 squared is 9 plus 16. And what's 9 plus 16? 25. So D squared equals 25. Are we done? What's your last step? Square root both sides. So D equals what? 5. So how far did Frida walk if she goes directly from her house to Dawn's house? 5 blocks. So Frida walks 5 blocks. Now, in a sentence, what did we use to solve this? Pythagorean theorem. So I want you to write, I used Pythagorean theorem. To determine the distance. Okay, this part telling me which theorem you used is called justifying your answer. Okay, so if I ever ask you to justify your answer, I want you to tell me what you used or explain to me how you got it. So we use the Pythagorean theorem because the whole thing looks like a right triangle. Okay, so we are going to turn the page. Okay, so number 8 says, it wants us to complete the summary of the steps that we took to determine the direct distance between Dawn's house and Frida's house. D is going to be the distance between the two. So the first thing we did was the distance between Bert's house and Frida's house. What expression did we use to determine the distance between Bert's house and Frida's house? 7 minus 3. So plug that in. 7 minus 3 squared. Because remember we squared it, which is how we got 4 squared, which is how we got 16, right? Okay. What about the distance between Dawn's house and Bert's house? What expression did we use there? 5 minus 2, and we squared the whole thing. And that's how we got 3 squared, which is how we got 9. Now, at first, we didn't know the direct distance between Dawn's house and Frida's house. So what variable did we give that? D. And what did we do to it? You had to square it. So was all equal to D squared. So if we go down a step, we simplified the 7 minus 3 into 5 minus 2. Did we do anything to the D squared yet? No, so bring it down. Then when we simplified the 4 squared and the 3 squared to get 16 and 9, did we do anything to the D squared there? No, so bring it down again. Okay, so if we read straight across, this is what we got. The first thing we did was the distance between Bert's house and Frida's house. 7 minus 3 squared plus 5 minus 2 squared equals d squared. That's still Pythagorean theorem. We're just showing all the steps in between. Then we simplified, and that gave us 4 squared plus 3 squared equals d squared, which is where we started, right? And that gave us 16 plus 9 equals d squared. And then what would the next step have been? 25 equals d squared. And then what did we get for our answer? 5 equals d. Okay, so we were just filling in the boxes of all of our steps. The main thing that I wanted you guys to see here is that when you did this in number 7, so in number 7 we started with 3 squared plus 4 squared. We actually got those 3 and that 4 from 7 minus 3 and 5 minus 2, right? Okay, so I just wanted you guys to see the whole thing. So let's look at this next part and read along with me. So suppose that Frida's, Bert's, and Don's houses were at different locations, and we don't know exactly what the points are. We can generalize their locations by using x1, x2, y1, and y2, and still solve for the distances. So let's take a look. Let's say that Don and Bert are still directly north and south of each other, and Don's location is x2 and y2. Which coordinate is the same between Don and Bert, the x or the y? The x. So Bert's x-coordinate is still x2. Okay, does that make sense? Because it's the same. Frida's location is x1, y1. What is the same between Frida and Bert's location? The y. So Bert's y-coordinate is also y1. Okay? Just like if we were to put numbers in there, the numbers would be the same. When we generalize using just x's and y's, they still have to be the same because they're in the same location. Okay? So let's use the graph to determine the distance from Don's house to Bert's house, and we're going to call it dB. Okay? So the distance from Don's house to Bert's house. The x-coordinates are the same, right? Yeah, so those aren't the ones we subtract. What are the ones we subtract? The y's. So we would say that dB is equal to, let's do y2 minus y1. And then after I know what those numbers are, we can substitute in. So try this now for part B and do the distance from Bert's house to Frida's house, and we're going to call it BF. Guys, what did you get for the distance between Bert's house to Frida's house? We're subtracting which values? The x's. So it's going to be x2 minus x1, okay? So we're just generalizing now. We are not putting numbers in here. So this would be in case we didn't have numbers, okay? So let's flip it over then. Can we still use Pythagorean theorem to determine the direct distance? Yes. Okay, so that's what we're going to do for number 10, and I will do this part with you. Use the Pythagorean theorem to determine the distance from Don's house to Frida's house. So they are giving us the points as our segment distances. So that would be df, and then what do we always do with Pythagorean theorem? Square it, equals. So df is the direct distance between Don and Frida, and what would we have to do then to get the legs? What are our legs? dB and BF. And what do we do with those? Square and add, right? So that's going to be BF squared plus dB squared. This is still Pythagorean theorem. It's just instead of A, B, and C, I'm giving you the endpoints as your labels, okay? Let's substitute what we know. Do we know anything, can we substitute anything in for dF squared? No, so leave it as dF squared. What about BF? Is there anything we can substitute there? What did we put in for BF? x2 minus x1. So let's substitute. So that's going to be x2 minus x1, and then we keep the square because we were just substituting BF. Plus, what can I substitute in for dB? y2 minus y1. And then we have to keep the squared on it. Okay, so the question wants to know, though, to get df by itself. So what did we do? how would we get rid of the square on the left-hand side? Square root the whole thing. So if we square root the whole thing, that would get df equals this whole square root, and then keep everything on the inside. x2 minus x1 squared plus y2 minus y1 squared. We're really just doing the Pythagorean theorem. It's just that we don't have numbers to plug in yet. Okay? This is called the distance formula. So guys, you just derived by yourselves the distance formula. The distance formula states, I'm going to highlight it right now. You don't need to highlight it right now. Just put a box or underline it. That if x1 and y1 and x2 and y2 are points on the coordinate plane, then the distance is given by this formula. You are going to need it. Either put a box around it. If you have a highlighter, highlight it right now. But we're going to be using the distance formula here. Okay? So then it took our little triangle and it showed us what we mean. So here's our triangle. The distance between these two, the absolute value indicates that the distance is always positive, because can we have negative distance? No. So it actually doesn't matter which ones you subtract first, because the distance always comes out positive. And then that's what these absolute values mean. And so we're just using Pythagorean theorem then to solve for the missing distance, given 2 points. So let's turn the page, and we're actually going to do some problems. So number 12, we are going to calculate the distance between each pair of points, and we're going to round our answer to the nearest tenth if necessary. That's 1 decimal place, okay? Okay, guys, so let's plug it in. So the first thing we need to do to use the distance formula is to identify which point is our x1, y1, and which one is our x2, y2. So which one do you guys want to make x1, y1? 1, 2. So here's what I always do. I always label it x1, y1 underneath so I know which one is which. And then let's make 3, 7, x2, y2. So let's plug everything into the distance formula. So the distance is equal to, in a big square root, we first subtract the x's. So do you guys want to do 3 minus 1 or 1 minus 3? 3 minus 1. Now remember, it doesn't matter which one you subtract first. That just means, though, that on the next one you have to subtract the same one first. Does that make sense? So since we use 3 first, when we subtract the y's, we need to use 7 first. So that's going to be plus 7 minus 2 squared. So the distance equals the square root. What is 3 minus 1? 2. So 2 squared plus 7 minus 2, 5 squared. So the distance is the square root. 2 squared gives me 4 plus 25. So the distance is equal to the square root of what? 29. Now, is that a perfect square? No. So we are going to need to use a calculator. I already did the math for you, and since we're starting to run short on time, it comes out to approximately 5.4. And that's your answer. And that's the distance between those 2 points without having to graph it and do all the steps to Pythagorean theorem separately. So